Hello everybody and welcome to this lesson, that is Theory of Production. First, let us define what production means. Production means it is a conversion of input to. So before going to the main concept of production, let us see different names of input. Inputs can be named as factors or factor of production or resources. And output can be named as quantity, alternatively total product or product. In general, production involves the transformation of inputs to the output, but during this transformation, there is value added. We have to add value. We have to add value in the conversion process. Production function defines the relationship between inputs and the maximum amount that can be produced within a given period of time and under a given level of technology. It defines the relationship between input and the maximum amount of the output. As we know, the main concern of the manager is to be efficient both technically and economically. So, to achieve that efficiency, a manager needs to ensure the production function. That means the relationship between the input and the maximum amount, the maximum output. Mathematically, Q can be expressed as a function of its inputs. Q is the level of the output, and X1, X2, and Xk are inputs used in the production. When we restrict those inputs as labor and capital, that is only two inputs are used in the production, so Q can be explained as a function of L and K. That means labor and capital. We know that profit is the difference between total revenue and total cost. That is, total revenue minus total cost provides a profit. So every manager is aiming to achieve the maximum profit, and many managers are more interested in the profit equation than the cost production. To achieve the revenue-oriented decision or to achieve maximum profit, a managers need to choose the optimum level and mix of advertising media, set the price of the product, make decision to expand new market, to search a new market, or to add new product lines. Even the decision to buy or merge with other firms may be highly related with maximizing the profit of the organization. In general, managers make product decisions in two aspects, that is short-term production decision and long-run product decision. By the way, this short-term production and long-run production does not have any relation with the time frame. Rather, in short-run production decision-making situation, a manager must produce with at least one fixed input and other variable input. If there is at least one fixed input and the remaining inputs are variable, so that is called as short-run production decision. If all the inputs are variable, if an organization can get enough time to vary, to change all the inputs, so that can be termed as long-run production decision. For example, if the amount of plant and equipment are fixed to produce the firm's output, so managers can change production levels by hiring or by increasing labor and raw materials. Once the equipment and the plant and the equipment are fixed, so the manager can increase the production by changing the variable input. In short-term production, the production is a function of only the variable input because the fixed input remains constant. That's why The production is a function of only the variable input. Let us see factor productivity in short run. For example, these are the units of K employed, that means the capital, and these are L employed, that is labor. So in this case, 4 units of K is used as constant, as fixed input, and we vary the labor 1, 2, 3. So as we vary the labor, so the product will be 24 with 4K and 1L, 39 with 4K and 2L, and with 3L it will be 52, and 60 with 4L and 4K, and so on. So as we add more and more L, so we can increase the product, the total product, the output. These are the problems. You can try by yourself, and if you have any question, you can write your comment. Let us see measures of productivity. Productivity can be measured by marginal product. Marginal product is the change in output resulting from a unit change in variable input. That means one additional unit of the input. Mathematically, it can be expressed as the change in quantity divided by change in input. And also, productivity can be measured by the average product. Average product is the total product per input used. That means total product divided by the input. Total revenue product is defined as market value of the firm's output, and it is expressed as total product times market price. Mathematically, it can be expressed as the total product, quantity of the total product times the market price. This is law of diminishing return, and it is an important concept in short-run production. In short-run production, law of diminishing return is very important concept, which clearly explains the combinations of input which can maximize the overall output, Law of diminishing return states that when more and more inputs of the variable input are applied to a given quantity of fixed input, we have variable input on one side and fixed input on the other side. So it states that when more and more units of variable input are applied to a given quantity of fixed input, the total output may initially increase at an increasing rate, then increases at a constant rate, and it will eventually increase at a diminishing rate, and finally even it will decrease. And there are some assumptions for the law of diminishing return to work. The first one is a state of technology is given, and second one is all inputs added to the production process have the same productivity level. The productivity of all inputs remains constant. And the other assumption is input prices are given. These are the assumptions for the law of diminishing returns to work. Law of diminishing return, this is, by the way, an example for the law of diminishing return. If a manager continues to expand a number of workers on an assembly line, here an assembly line is fixed, so the variable inputs are the workers. As the manager continues to expand the number of workers on a single assembly line, the manager would eventually reach a point where the workers were packed like sardines along the assembly line. So they can't work effectively because of the crowdedness. The employees are crowded in the assembly line, so they cannot work effectively, getting in one another's way and resulting in the less output than before. As the manager adds more and more numbers of workers, even ultimately the output decreases. That means a negative marginal output appears. And this means that the last unit of the input actually reduces the total product. The last number of workers or the last workers will have a negative value of marginal product, which decreases the total product. Mathematically, the case of diminishing marginal return requires the first partial derivative of total product to be positive and the second partial derivative to be negative. These are the criteria for diminishing marginal returns. Let's see graphically. Graphically, this line represents, this curve represents the total product, and this line represents, the curve represents the average product, and the lower curve, this one, is the marginal product, Let us see stage by stage. At stage 1 here, it means here at stage 1, the marginal returns increasing the marginal return. That means total product rises at an increasing rate. As you see. And marginal product also increases at a decreasing rate. Here, marginal product increases, but at a decreasing rate. But average product is also increasing, and it reaches its maximum point where, that means at stage 2, where marginal product equals average product. This is the point when AP reaches its maximum point. That means average product reaches its maximum point. At stage 2, total product is increasing, but with diminishing return, with decreasing return. Decreasing rate, that means decreasing rate, not just like stage 1. It is decreasing rate. It increases, but with a decreasing rate. Here, the marginal product begins to decline. As you see, the marginal product begins to decline, begins to decrease in this stage. And total product reaches its maximum point when the marginal product reaches 0. As the marginal product reaches 0, equals 0, the total product reaches its maximum point. Total product reaches its maximum point at MP equals 0. And in stage 3, total product begins to decline because at stage 3, marginal product starts to become negative. So it decreases, total product starts to decline, and marginal product becomes negative. And average product continues to decline. Average product also continues to decline because the total product also starts to decline. Here, negative marginal returns. And the table also shows the stages. In the first stage, increasing returns, and second stage, diminishing returns, and third stage, negative returns. And during this stage, the total product starts to decline, and the average product also declines here. You can see with these numbers. You can see with the numbers. Now let me ask you one question, that is, in short run, rational firms should be operating only in stage 2. What is the reason behind to operate in stage 2? The reason behind to operate in stage 2 is that in stage 2, first let us see stage 1. Why not in stage 1? In stage 1, we are not using all the capacity of the fixed resource, the fixed input. So we can add the variable input so as to achieve maximum product or high volume of output. So when we add variable input, so the total product increases. And at stage 2, the total product reaches its maximum point where the marginal product reaches 0. So around that point, we can produce maximum amount of the product. So that is the place where, or the point where the rational firms should operate. If the production function is expressed by linear equation, that is Q expressed as function of capital and labor equal to AK plus BL, so the marginal product of K is A and the marginal product of L is B. Marginal product can be calculated by the first derivative of the total product. If we want to calculate the marginal product of the capital, so marginal product of capital is the first derivative of the total product with that of the capital. So when we derive, so we can get A. When we derive total product with that of K, we get. Now let us see marginal revenue product, total labor cost, and marginal labor cost. Marginal revenue product is equal to change in the firm's total revenue product resulting from the unit change in the number of inputs used, or mathematically it can be expressed as the change in total revenue product over the change in the inputs. And total labor cost can be defined as the total cost of using the variable input, labor, computed by multiplying the wages, the number of laborers times number of their wages or the salary. Marginal labor cost is the change in the total labor cost resulting from the unit change in the number of variable inputs used. And mathematically, it is W, that is wage. Here is an example. Try it by yourself, and if you face any difficulty, write a comment. This is the important concept, that is applications of law of diminishing return. There are several applications for the law of diminishing returns. The main application for the law of diminishing return is it helps to identify the rational and irrational stage of the operations. As we discussed previously, there are three stages of production. So a manager can understand which stage is rational and which one is the irrational stage. And the second one is it gives answer to the question, the most important question, that is how much to produce. This is the main question that should be answered by a manager before starting a production. So this can be answered by understanding the law of diminishing returns. And the next application is what number of workers to apply to a given fixed input so that the output can be maximum. As we discussed before, just adding the variable input on a fixed input, adding continuously, adding more and more variable input may not provide maximum output. So the diminishing return provides us what the number of workers to apply to a given fixed input so that the output is maximum. Managers ensure firm's operation on the production function, and firms uses the correct levels of the input. In general, managers need to ensure the maximum amount of products with the correct, the optimum levels of the input. So this is an example. So try by yourself, and if you get any difficulty, write on the comment. the role of a manager in production process is mainly, the first is to ensure the firm's maximum production, and second is to keep the optimum levels of input utilization, to keep the correct levels of the input. Let's take one example. If we assume labor as a variable input, before adding additional labor, the manager must ensure that the maximum possible outcome is obtained from the first worker or the first labor. To drive that, a manager should come up with incentive mechanisms and other methods to increase the productivity of the existing labor. The second example is, let us assume that the output produced by a firm can be sold in a market at a price of 3. Furthermore, assume each unit of labor costs 400. How many units of the labor should the manager hire to maximize the profit? By the way, let us see this example with the following table. The price of the output is $3, and these are the variable inputs. The variable inputs, this is the price of the output, and this is the marginal product of labor, and this is the value of marginal product of labor. Value of marginal product of labor. It can be obtained by multiplying the price of the output with that of marginal product of labor. Price of the output times marginal product of labor provides us value of marginal product of labor. And these are the unit cost of the labor. So, as we add more and more variable inputs, that's labor, with a unit cost of 400, so we are increasing the marginal product of labor, and ultimately it becomes negative. So here we need to compare the value of the marginal product of labor. That means the value which is obtained from the additional labor, the value which is obtained from the last labor. So here, as we compare, this one is greater than 400, and this one is also greater, this one is also. As far as this side is greater than this side, so we can continuously add more and more input variables, that is labor. So here it is less than 400. So adding 10 incurs loss. By adding the 10th labor, we incur loss. Because the value that's obtained from the 10th labor is less than the cost incurred due to the 10th labor. So we have to stop here. We have to stop at the 9th labor. This is what we have discussed before. Now let's start the other portion, that is long-run production. In the long run, a firm has enough time to change all the inputs. In this case, the long-run production decision, all the inputs become variable input. Unlike that of the short-term production. In short-term production, at least there should be at least one fixed input, but in the long run, all the input become variable input. Thus, a manager can choose to operate in any size plant with any amount of capital equipment. The long run is the period in which a firm can adjust or can change or can increase or decrease all the inputs to align with the changing condition. So, here, In order to determine the optimal combination of the input, there is a concept that is a return to scale. Optimum resource combination in the long-run production process is described by return to scale and isoquant. By return to scale, we mean that the resulting increase in total output as all inputs increases. Because in the long run, all inputs are variable input. So return to scale means the resulting increase in total output as all the inputs increases. And isoquant is a combination of inputs that yield the same levels of output. The output remains the same, but the combination may vary. And the other concept is marginal rate of technical substitution is defined as the rate at which the producer can substitute between two inputs. There are two inputs and the producer can substitute one input with the other. So this is what we call marginal rate of technical substitution. Let us see with table. As we increase the inputs of K and the inputs of L, so these are the outputs. The output for 1 K and 1 L, 1 K and 1 L, we get the output of 4. For 2 K and 2 L, we get the output of 18, and the same is true for the others. Along this diagonal, we get the output. This is the return to scale. This is the return to scale. For most production function, the same output can be produced using different combination of capital and labor. Sometimes we may compensate the labor with capital. We may increase the capital and we may decrease the labor. For example, when less labor is used, more capital can be added to reach the same level of production. When the input substitution is possible, we call this kind of production variable proportion production. On the other hand, when there is one and only one ratio or mix of the input that can be used to produce a good, we call this fixed proportion. In this case, we cannot change the proportion. We cannot change the proportions. Just like unlike the variable proportions, we cannot vary the input combination in the fixed proportions. Let us see some more detail about return to scale. Return to scale can be categorized into three. If all inputs into the production process are doubled, three signals can happen. The first is output can be more than double, so we call this increasing return to scale. And output can be exactly double. This can be called as constant return to scale. And output can be less than double. That means decreasing return to scale. Let us see graphically. Here, as you see, the first inputs are K and L. As we double K, it becomes 2K and 2L. So during that time, the output will be this one, which is less than 2x. So it is a decreasing return to scale. And in this case, the first one is K and L when we doubled labor and capital to L and to K, and it is above 2x, above double. The output is above double, so it is increasing return to scale. And this one is when we double the input, the output will be doubled. So this one is constant return to scale. And this table shows the isoquant. Isoquant is all possible combination of the input which produces a given level of output or the same levels of output. For example, when we combine 6K with 4L, So we get 73, and when we combine 4K with 6L, we get the same output, that is 73, and when we combine 3K with that of 8L, we get 73. So this line is an isoquant curve, which shows different combinations of the input that provide the same output, but it has different combination of the input. This is what we call isoquant curve. Let us see some more details about isoquant curves. There are some properties for isoquant curves. The first one is isoquant have a negative slope. That means in order to get one input, we should offset, we should give up the other input, we should replace the other input. The isoquant curves are convex to the origin. As you see, they are convex to the origin. This indicates that as we have more and more of one input, so we are willing to exchange the other inputs that we don't have, that we have less. We are willing to exchange with more of what we have with less of what we don't have. And the other property is isoquant cannot intersect or be tangent to each other, because isoquant curves, they have the unique quantity, unit outputs. They explain unit outputs which have different combinations. And the upper isoquant represents the higher level of the output. As you see from these figures, this is the upper isoquant, and it has highest levels of the output, As we go from this to this, it increases the output. And the other point is, in the long run, in order to measure return to scale, we can use coefficient of output elasticity. And coefficient of output elasticity can be expressed as percentage change in quantity divided by percentage change in all inputs. If coefficient of elasticity is greater than 1, then the return to scale is increasing return to scale. If coefficient of elasticity is equal to coefficient of output elasticity is equal to 1, then it becomes constant return to scale. It's like this. And if coefficient of output elasticity is less than 1, then it is decreasing return to scale. It's like this, decreasing return to scale. And this is an example. Let us see it. This is the input, number of labor or number of workers, and this is the total product, and this one is the average product, and this one is the marginal product. As we add more and more number of workers, the total product increases, and here it starts to decrease. And here is the average product. The average product is increasing, and after this it starts to decrease. And in the case of marginal product, first it increases, then it starts to decrease, and ultimately it becomes negative. So it is not economical to add the 10 workers, because it decreases the overall total product from 318 to 314. So this one is adding the 10th worker is not economical. This is all about today's discussion. If you have a question or a comment, you can write it below. Have a good time. Thank you.